Good day, dear colleagues. For your attention, we present a report on the topic, the peculiarities of a symbol classification and recognition of expression structure system development. Computer vision is an activity in which statistical methods are used to obtain data and models built using geometry, physics, and learning theory. Computer vision is used quite widely, both in all fields. For example, mobile robot control, military applications, industrial surveillance. In the new ones, human-computer interaction, image retrieval in libraries, medical image analysis, and realistic rendering of simulated scenes in computer graphics. A distinctive feature of computer vision is the extraction of descriptions from images or sequences of images. For example, such an aspect of computer vision is the detection of the structure by motion allows you to get an idea from a series of images about how the camera moves and what is depicted in the picture. In the entertainment industry, similar methods are used to filter out motion and build three-dimensional computer models of building with structural integrity. With the help of the few photos, you can get good, simple, accurate, and convenient models. Therefore, considering the mentioned features, an urgent task is analyzing symbol classification in known systems and recognition of expression structure for the development of a software tool for solving the given task. The problem created is not new, and therefore there are many studies related to it. We will announce the more famous scientific works. Richard Zanibi's works analyze the baselines present in the expressions. Consider the dominant baseline, the line on which the expression will be written, and the nested baselines corresponding to the indices. In the first step, a tree is built based on these baselines. The line recognition method is performed in 4 stages: stroke recognition, structure recognition, character recognition, and subscript recognition. Richard Tapia and Paul Rojas Gonzalez first obtained baselines like Richard Zanibi and recursively built a minimal tree in which each node is a symbol. Next, the distance between the two symbols is determined depending on the value in the range in the other. And summarizing the research, it can be concluded in that some recognition methods and based only on special considerations such as baselines. Other methods use rule-based systems such as grammar and analyze an expression to interrupt it. Part of the algorithms considers the knowledge of mathematical symbols and operators and their special properties. At the same time, not all studies use machine learning methods. So the classification of the symbols and recognition of expression structures with the subsequent development of a software tool for solving the given task and urgent issue. The purpose of this research is to develop a pattern recognition system, or rather a mathematical expression recognition system based on machine learning methods, where symbol classification and structure analysis are separate tasks. The conducted research will provide means for classifying symbols and determining the structure of expressions, including mathematical ones. To achieve the goal, the following task must be solved: to analyze the existing approaches and method uses in the process of symbol classification and recognition of the structure of the expression, to determine the main task that arise at the same time, to develop the structure and determine the main components of this recognized expressions, to formulate an algorithm of symbol classification and recognition of an expression structure, and to carry out its mathematical description using the algebra algorithms, to design a software system using the object approach, to construct and apply a software system that implements the process of symbol classification and expression structure recognition, and the results of the study solve the actual scientific and practical task of analyzing the structure of an expression and classifying symbol using a small amount of knowledge about the syntax of mathematical expression. Mathematical expression recognition is a task which representing a mathematical expression is interpreted by a computer so that it can be stored, processed. and reused. Expression recognition consists of two stages. Symbol recognition. Each foreground pixel in the image belongs to a symbol, and each symbol has value and expression and conveys some information. And the next one, which you can see on the news, is on this slide. Character recognition task is a procedure by which each character is recognized and classified. This is not an easy task due to the anonymous number character, given that there is no dictionary on words like for text recognition. Quantum mechanics, for example, define new uses for and to denote quantum states. The symbol, you can see symbols on this work. These are examples where existing symbols are used for a different purpose. When we analyze different symbols separately, we can see different spatial properties. For example, the relative position of the superscript are seen in fish 3. Will not look locally the same with the symbol B or Q. However, at the global level, all subscripts must be written in one line. At the same time, the input format is an image of a handwritten mathematical expression. Tables 1 and 2 show the character classes and relations used respectively. The next stage of the research was the system design. According to the object approach and the UML language, the class diagram is a structured diagram type in the UML used to visualize the structure of classes and relationships of the software systems. Classes and the relationships you can see on this diagram. The next stage was creating a functional model using the algebra algorithms. And the first stage of the implementation of the algebra algorithms is a description of unit terms and the synthesis of sequences, which is given below. You can see the sequences on this slide. As a result of using the properties of the algebra algorithm, we subtract the common unit terms, but by the sense of the elimination operation, obtain the following formula of the algebra algorithms. Next, on this figure, you can see the evolution of the main base structure, the stack of those characters. Each time the symbol is a parent, we created base structure and added to the last symbol task. The stack contains baseline structure objects rather than contents object, simply updating the entire structure during the recognition process. The system was tested with 1, 2, 5, and 7, and 10 iterations. The result was that 440 out of 570 characters were successfully classified. Results of testing you can see on this slide. And as a result of the research of the existing methods and approaches used in the process of classifying symbols and determining the structure of expressions, we analyzed it, which made it possible to identify the peculiarities of the application and outlined the range of problems that arise. An iterative algorithm was developed to use the mutual constraints between the structure and the type of symbols. One pass algorithm was implemented, which included search with returns, which ensured fast recognition of the expression structure, and its representation was carried out using the algebra algorithms. Next stage was designing a software system using UML, object-oriented approach, and the display of the creating diagrams using UML. And the current moment, the structure, the software solution works in the form of prototype. Further research will be directed to testing and improving for the system, eliminating conflicts and expanding functionality in accordance with the specified requirements. Thanks for your attention.